All right, so second day of some radicals. All right, here we're going to simplify. Now, if you watch the previous video for 5.2 day one, you'll see that when there was a point where we were combining some like terms here. All right, so really quickly, just reviewing, because we have square root of y, square root of y, because those are exactly the same. All right, the thing we do is we add those numbers in front. All right, it tells us to add. It tells us to add, adding together. So because square root of y are exactly the same, we add the 5 plus 6. So we end up with 11 times the square root of y. And for you guys that always ask, is that it? Yes, this is it. That's all you do. All right, that's all you do here. Now, if you look at this part B, the third root of x, the third root of x. Do you agree they're exactly the same? Yes. So what are we going to do? We're just going to combine those numbers that are in front. All right. So we end up with here 8 times the third root of x. And we're done. That's it. All right. So look at C. What are you noticing is a little bit different? All right. With C, the thing that you notice is a little bit different is the stuff underneath the radical. The stuff underneath the radical is not the same. So we have to do something to make it the same. All right. So we're going to be doing stuff to make those two exactly the same. So I look at this thing and it says the square root. So I know there's a 2 sitting there. Remember, people in math are lazy. If they don't have to write something, they're not going to. So we have to know that there's the index is 2 or n. All right. Remember, we kept calling the index n. All right. So we have to know that that's 2. Well, what does the square root of 9 mean? Well, 9 just means 3 squared. All right. So again, oh, damn it. All right. So we still have that 2 sitting there. All right. And the reason why I rewrote 9 as 3 squared is because I want the index and the exponent to be exactly the same. All right. So now if I look at this w here, w to the fifth, I need to do something to that w to the fifth so that the index and that exponent are exactly the same. All right, so that's what I'm shooting for. Well, do you agree that I could rewrite w to the fifth as w squared times w? All right, think about this for a second. I want to see if you can agree, if you're going to agree with me. What happens when we're multiplying and the bases are the same? Do you agree that we are going to add those exponents, and this one would have an exponent of 1? Do you agree that we add those exponents? Yes? All right. So if you agree that we're going to multiply, when we multiply, we add those exponents, then I'm hoping that you'll agree with me that we can rewrite w to the fifth as w squared times w. And again, what was the reason for it? All right. The reason The reason that I did that is because I want the index and the exponents. I want all of those to be the same. Okay? All right. Now let's move over. Let's move over to minus w, and then I have the square root of w to the third. Well, again, there's that 2 sitting there. But now this time I want to change. Can I do something to change that 3? Well, again, if we do this same thought process, I can say w to the third is w squared times w to the first. All right. So I have w squared times w to the first. And the whole reason for that is the index and that exponent are exactly the same. Okay, now I hope I'm not overcomplicating this, but I'm just trying to get you to think through it. Now, if I would have just asked you, what is the square root of 9? You guys would have rolled your eyes at me and said 3, right? Nothing difficult. So, because the reason why the answer is 3 is because this index, this index, and that exponent kind of cancel each other out. All right. So when I'm doing this problem, this 3, because the index and the exponent are exactly the same, this 3 now is going to be written outside. Same thing with this w here. This w is going to come outside because the square root of w squared is just w. And then I have that w there also. All right. Now, some of you guys said you do like the colors. All right. So that 3 is right there. This w is right there. This w is right there. All right. Now, can I do anything with this w here? No, I can't. I can't do anything with that w because there's no square down it. All right. So it's going to stay underneath. It's going to stay underneath the radical. Okay. Now let's move over. W. All right. So this w is that w. All right. So it was outside. I brought it outside. Now here, this w to the second is going to get dragged outside because the squared, let me change colors here, because that exponent of 2 and the index of 2 and this exponent of 2 are exactly the same. So it gets drug outside. Now this w here, all right, let me stay consistent with the colors, guys. Sorry. All right. This w there stays underneath because it only had an exponent of 1. There wasn't enough. There wasn't enough with the exponents to yank it out. Okay. Now let's look. Let me see if I can erase without erasing everything. Okay. So let's look at this now. 3w times w. Well, that all that gives me is 3w squared times the square root of w minus. Now let's look over here. W times w. W squared times the square root of w. All right, I'm going to stop right there. You notice we did all that work so that this and this are exactly the same now, just like these two problems here. All right, just like those two, where the stuff underneath the square root was exactly the same underneath the radical. Okay, so since they're both underneath the radical and they're both exactly the same, what can I do? I can combine those two. All right. So last step, 3w squared minus w squared gives me 2w squared times the square root of w. All right. Let's look at this one. All right. So what are we noticing? I have the third root. Okay. I have the third root here. So again, what do I want? I want the exponent and the index. I want the exponent and that index to be exactly the same. So I'm going to have to do a little bit of work to get there. All right, so let me recopy that 12. The third root. Now, can I do anything with this 2? No, I can't do anything with that 2. All right, I can't break 2 down to anything else. So I'm just going to rewrite the 2, and that's going to kind of help me cheat a little bit later. Now, what about z to the 5th power? Can I do something to that? Can I do something to z to the 5th power so that I can get an exponent of 3? Well, I hope you agree with me. Z to the 3rd times z squared will give me z to the 5th, right? Because all I'm doing is I'm just adding those exponents together. All right, so 3 plus 2 gives me that 5. Well, the reason why I'm doing this, z to the 3rd times z squared, the reason why I'm doing it, one more time, is I want the index and that exponent to be exactly the same. All right, that's what I'm looking for. I want the exponent and the index to be the same because I want to be able to yank it out from underneath the radical. Okay, so now let me erase a lot of this mess. Let's move on to the next part. Minus. All right, so I have that z that's sitting outside, and then I have the 3rd root of 54. All right, now I need to be able to break that 54 up. And this is where, remember, I was telling you I want this 2. I'm going to use that 2 to cheat. Okay. So what I'm going to do is I'm going to grab my calculator and I'm going to do 54 divided by 2. All right. So 54 divided by 2 gives me 27. So I know I'm going to have 2 times 27. But 27 doesn't help me. So I want to know is, can I write 27 as something to the 3rd power? Okay. Can I write 27 as something to the 3rd power? Because why do I want something to the 3rd power? Because that index is to the 3rd. All right, that index is 3. All right, so a little trick that you can do on your calculator. All right, little trick you can do on your calculator. Let me erase this so I have a little bit of room to write. Is on your calculator, do 3. All right, so really what you're doing is the 3rd root of 27. All right, so that's what you're doing on your calculator is the 3rd root of 27. And when you do that, all right, so if you take the time right now, grab your calculator, type in the 3rd root of 27, it's going to give you 3. So really what this is saying is 3 to the 3rd power is 27. All right, so what am I going to do? I'm going to take that 27, and instead of writing 27, I'm going to write it as 3 to the 3rd. Now, can I do anything with that z? No, I can't do anything with that z because it's only z squared. All right. So let me erase that. Okay, so now I'm looking at this thing. I used that 2 to help me cheat because 2 is there also. All right, so I use that 2 to cheat. Now I start looking at this thing. What can I yank out? All right, what can I yank out here? Well, I have the 3rd root of z to the 3rd, so I can yank that z out. So I have 12z, all right, there it is right there, times the 3rd root of, and what's left behind, all right? So for you guys that like all these colors, that z is now right there. And then that 2 stays underneath because I couldn't do anything with it. It wasn't raised to the third power. And then z squared, z squared. Okay? Minus, there's that original z that was sitting out there. All right, let me move it over a little bit. Now, can I do anything with this 2? No. So it's going to stay underneath the radical. All right, so it's going to stay underneath the radical. All right, so that 2 stays there. Now, what about this 3? I'm going to yank it out from underneath because it has an exponent of 3. All right, again, what did I look at? The index and that exponent. So I was able to yank it out. Can I do anything with this z squared? No. So it stays underneath the radical. All right, stays underneath the radical because I needed an exponent of 3 and I only had 2 there. So since I only had a 2, I can't do anything with it. It stays underneath. Okay, so let me rewrite this a little bit. So I have 12z times the third root of 2z squared minus 3z times the third root of 2z squared. Now, what do you notice? The very first thing I noticed is this and this are exactly the same. That's what we want. We want those to be the same. Okay? We want those things to be the same. So now what am I going to do? Because those two z squares were the same, I'm just going to combine 12z minus 3z. Those are like terms. All right? I can combine those together. So 12 minus 3 gives me 9z, and then the third root of 2z squared. All right, last one. All right, so again, I'm looking at this thing. Very first thing I'm looking at now, oh crap, I have something to the fourth power. So now I want to start thinking something to the fourth. All right, something to the fourth. All right, let me drag this 16 down. The fourth root. Can I do anything with that 3? No, because I need something to the fourth power. And I can't break 3 up. So I'm just going to leave that 3. But again, in the back of my mind now, I'm going to use this 3 to cheat over here. All right. I'm hoping that you guys are starting to follow me there. I'm going to use that 3 to cheat in the next one. Can I do anything with x to the 6th? All right. So that's my question. Can I do something with x to the 6th? Keep it in mind. What do I want? I want this index of 4. So I want something to the fourth power. So x to the fourth. Well, if I take 4 from that 6, what am I left with? 2 left. All right. So x to the fourth, x squared, minus. Let me drag that x down from that was out in front. All right. Now I'm looking at 48 here. All right. I'm looking at that 48. Remember I said I was going to cheat. I was going to cheat and I was going to use this 3 when I found that 48. So 3 times something. All right. So again, grab your calculator. 48 divided by 3 gives me 16. Now, I want to be able to write 16 as something to the fourth power. And why to the fourth power? Because of that 4 there, that index of 4. Okay? So again, remember, I want this and that. Oh, that was stupid. Blue on blue. All right. But anyway, I want those 4s to be exactly the same. All right. So what can I write? Again, remember what I said is grab your calculator. Grab your calculator. Now do the fourth root of 16. When you do this, when you do the fourth root of 16, it gives you 2. So what can I write here? I can write 2 to the fourth power. All right, is everybody okay with that? Now, if you grab your calculator and did 3 times 2 to the fourth, you'll notice that it'll give you that 48 back. Okay? So now, can I do anything with that x squared? No, because I only have an exponent of 2. I can't break it up anymore. So x squared. Okay? Now, let me get myself some room to write here. All right, so I have that 16. Can I do anything with that 3? No. So it's going to stay underneath the radical. All right. So here's my radical, the fourth root. That 3 is going to stay underneath. What about this x to the fourth? Well, because that index and that exponent are the same, I'm going to be able to drag this x out. Okay. So that x is right there now. And then this x squared stays underneath the radical. Again, because it has an exponent of 2, I needed an exponent of 4 to drag it out. All right, minus. There's my x. There's my fourth root. Can I do anything with this 3? No. So it stays underneath. This x to the, excuse me, 2 to the fourth power. All right, that I'm going to drag out. I'm going to drag that 2 out because, again, it had an exponent of 4. The index, that index and that exponent are exactly the same, so I'm going to drag it out. And then x squared, I can't do anything with it, so I'm going to rewrite it. All right, and there it is. Okay, now let me just rewrite it one time because of all these colors. Looking all psychedelic and stuff, it's starting to freak me out. Okay, again, what am I noticing? I look at this thing and I'm like, the fourth root of 3x squared, the fourth root of 3x squared, exactly the same. That's what I want. I want them to be the same because I want to be able to combine the stuff that's in front. Well, looking at the stuff in front, 16x minus 2x. Well, 16 minus 2, 14x. And then times the fourth root of 3x squared. All right, so this one's a little bit tougher than the last lesson, but it's not horrible. Okay, so please make sure you guys ask. Please make sure you're practicing.